Good afternoon, good evening to some, good morning to others, even good night to some, I've noticed. My name is Mark de Gouw. I'm an independent consultant from the Netherlands. I'll be moderating this session. I'll be watching the questions and answers in the Wova app, also watching the chat. And I'd like to introduce Jim Steele, who's gonna talk about one of my favorite subjects, terminology. So Jim, the floor is yours.
Thank you, Mark. So yes, as I'm going to talk about terminology today, this is a talk I've given at some of the previous DevDays, but I've changed the way I'm doing it today. So hopefully it's a little more entertaining than previous ones. So I'm Jim Steele, as Mark mentioned. I'm the team leader for health data and FHIR at CSIRO's Australian eHealth Research Centre. So CSIRO is Australia's national science agency, and we're the eHealth part of it. And most of what I do there is I'm a software engineer on our Onto server product, which is the national FHIR terminology server for Australia, and as of last week, also for the NHS in the UK. So what we're going to do today, rather than sort of working my way through the FHIR terminology services API, sort of operation by operation and resource by resource, I'm going to try and follow the journey of coded data as it moves through the sort of FHIR ecosystem. So how coded data gets selected and how codes get found in the first instance, whether that's by a patient or a practitioner, what those codes look like on the wire when they're being sent around as part of FHIR resources, when they're received by someone, how they get validated, and to check whether they're legitimate codes for the purpose that they were intended for, and then how you can start to query based on those codes and start to do some analytics on those codes once they're in the system. So as I go through this, I'm going to tell a bit of a story based on The Wonderful Wizard of Oz, a book that a story that many people will know from a book from about 120 years ago, and I owe a great debt to William Denson, who's the illustrator of that book back in 1900. So I've got some of his pictures through the presentation. And the reason we're talking about this is that terminology really is a very important part of FHIR. So what we often see is that the codes that we see in FHIR resources often represent the most meaningful parts of those resources. So that when you look at a condition resource, then it's the code for that condition that really tells you what condition it is. When you look at a medication resource, it'll frequently be the code of the medication that tells you what that is. So it really does carry a lot of the semantics that we used in FHIR. So it's a very important part of FHIR. And it's a little bit different to some of the other parts of FHIR, particularly in that it depends very heavily on operations, as well as the three main resources. So the three main resources in the FHIR terminology world, and there are a couple of others, but I'll mention those later on, are code system, value set, and concept map. Two of these are normative. So code system and value set have been normative since the R4 release of FHIR. A code system is some sort of set of concepts with a coherent meaning. So they're typically arranged in some sort of hierarchy, although they may just be a flat list. There's a whole bunch of metadata on the code systems. They'll advertise filters and properties, and we'll touch on how those filters can be used later on. And then they consist of a whole set of concepts, and each of those concepts will have a code. It will usually have a display term that's used for showing the code. It can have a definition, it can have synonyms, and then it can have a bunch of property values. It might have translations into other languages as well. The second resource is the value set resource, and a value set is some selection of codes that's drawn from one or more code systems. So in the vast majority of cases, we'll be constructing value sets, and we'll see value sets that are drawn from only one code system. But there are really good reasons why sometimes you want to bring in codes from multiple code systems into a single value set. And you can build up those value sets either by just using a list of particular codes that you're interested in, or you can define it intentionally by defining some rules that dictate whether a code is a member of that value set or not. And then the third resource in the terminology world is the concept map. So a concept map is a code-to-code mapping between concepts in one value set and concepts in another value set. And for each of those maps, you can also specify what is the relation that holds between those codes. So are they equivalent? Is one broader than the other? Is it just an unspecified relationship between the codes? And then that concept map can be queried later on to actually map between the codes. So in addition to those resources, as I said, the operations in terminology are really important. So on the code system resource, we have the lookup operation, which allows us to retrieve details about a code, the validate code operation, which we can use to test whether a certain code is a member of that code system, and the subsumes operation, which allows us to test whether there's a hierarchical relationship and in which direction that hierarchical relationship holds between two codes. On the value set resource, there's the expand operation, which is probably the most used operation in the FHIR Terminology Services API. That allows us both to retrieve a list of the codes that are a member of a value set, or also to search for a code within a value set. And then there's the validate code operation on value set, and that allows us to test whether a code is a member of a value set. And then finally on concept map, there's the translate operation, which allows us to provide a code and retrieve which codes that's mapped to according to the concept map. And the closure operation, which is defined on concept map, but is about sort of bulk querying of hierarchical relationships amongst codes. So we can, rather than just passing in two codes and asking how they're related, we can pass in a whole big set of codes and track how they're related over time as we add more codes in, which is very useful for server integration. And if I get time, hopefully I'll have an example of closure at the end of the talk. So the way that the Terminology Services API appears in a FHIR architecture can vary depending on how you've got your system set up. So most of the standard FHIR servers will have a terminology API implemented in them. And just using that as a Terminology Services API is a really simple way. It's for clients to use the Terminology Services API. There's a single port of call where they can go to execute all of their FHIR operations, to carry out all of their FHIR interactions. Alternatively, you might have a separate terminology server. So there are very specific server products that are made to be a terminology server, or you can use a general purpose server and just use it for terminology. And that has some advantages. If you've got multiple FHIR systems in your architecture, then you can have a single source of truth for all the terminology resources using an architecture like that. You could hide both of those servers behind a facade. And that kind of gives you the best of both of those worlds. You've still got a single FHIR endpoint for users to use, and you can still have a single source of truth for all of your terminology resources. And I think this is the best approach, is you can integrate your FHIR server with the terminology server in a more tighter, more meaningful way. So you can, again, still have that simple API endpoint and a single source of truth. But by integrating the two together, your FHIR server can support terminology-aware search. It can better support validation and things like that. So the story that I'm going to tell today starts with our patient, who's named Dorothy Gale, and she's not feeling well. She's had an accident, and she's going to make an appointment with her GP, Dr. Oz. So the first thing she's going to do is she's going to fill out a pre-appointment form. And we're going to try and look at how the Terminology Services API can help her to do this. So in this instance, she's going to provide some very basic demographics, name, age. She's going to provide her gender. She's going to find some sort of reason for her visit. And we can see here that's been implemented using a type ahead widget. So the first term that she seems to be finding there is an accident caused by a tornado. And she's provided some family member history as well. So for her aunt and then 3 of her friends who've got some medical conditions that she thinks could be relevant to diagnosing what's wrong with her and helping her get better. So how are these things on this form powered by the Terminology Services API? The first thing that Dorothy needs to do is select a gender, and the expand operation can help with that. So the expand operation, again, allows us to list all the codes in a value set. And the way we're going to use it in this case is we invoke it on value set, and we're going to specify which value set we're interested in using the URL parameter. So we pass in the URL of the value set we're interested in expanding. We send that request off to the server, and the server comes back with a value set. And importantly, that value set has an expansion element on it. So the definition of that value set might have had a compose element, which defines the rules for that value set, but the expansion is what comes back with the codes that satisfy the parameters that we passed into the expand request. So in this case, it's all codes, and it comes back with male, other, female, and unknown as the possible codes. It also comes back with the code system URL because, as I mentioned earlier, it is possible to have value sets drawing codes from multiple code systems. So we do need to specify which code system each of these codes has come from. And it'll tell us some other interesting things like the total number of codes. The offset allows us to tell whether this is a page in the expansion or whether it's the start of the expansion in this case, because the offset's 0. The next place where we might use that expand operation is in that family member history. So when Dorothy was choosing whether the family member was her aunt or her friend, then she was choosing a family member history relationship code. And if we don't know the URL of the value set that is important for that, then we can use the context parameter instead. So in this case, what we do is rather than saying the URL of a value set, we say the FHIR element that we're interested in expanding the possible set of codes for. And then the FHIR server will look up that structure definition, work out what value set it's bound to, and expand that as part of the request. So when we send that through, we can see that the server again comes back with a value set with an expansion element. In this case, there were 105 codes. So this is the, I believe it's an extensible value set on family member history, and it comes back with the first set of codes. This expansion actually has all of them in it. I didn't restrict it, so it would have 105 more codes down the bottom there. And then the final example I'm going to put up here for expand. The reason for visit is a little bit of a different case because the reason for visit value set binding is very, very big. It's hundreds of thousands of possible codes. So it doesn't really make sense for us to just send an expand request and get them all back. We want to be able to allow Dorothy to filter those down to just the ones she wants. So we can send through the expand request. We'll use context again, but we'll pass through a filter. And this is a text filter that the terminology server or the terminology API implementation is going to use to narrow down the set of codes just to those that it feels matches that filter. So she's put in ACC and TOR, and then the server, when we send that request through, will come back and say there are 6 codes that it has in that expansion, and accident caused by a tornado is the first, accident caused by a welding torch is the second one. She's probably not going to select that. So once Dorothy's entered all this information, it's going to be bundled up and represented as FHIR resources. So we'll have a bunch of family member history resources, there'll be a patient resource, and there'll be an encounter resource. And I'm going to use the encounter resource just to show how those coded values get represented inside a FHIR resource. And there are 3 data types that FHIR uses to represent coded data. The first is the code data type. And this is for the case where the FHIR element has narrowed down the code system that is acceptable for that element. So there's no variability for that. So all that we have to provide and all that will appear in the FHIR resource is just the code. We don't have to provide the URL of the code system that it comes from. So this status code of planned is a code data type. The second is a coding data type. So for coding, we do have to specify the URL of the code system that the code belongs to. We can also specify the display text for that code if we want to. And there's some other fields that we can provide. We could provide the version of the code system if we think that that's important. And we can say, as you can see down the bottom of the screen, we can say user selected to indicate that this code was specifically selected by the user. It wasn't something that was populated by an algorithm or a map or something like that. And then the third data type that we we'll see, and this is the most common, certainly in the R4 version of FHIR and moving forwards, is the codable concept data type. So the codable concept allows us to have multiple codings, which, for example, could be used to include the code that the user selected, as well as some other codes that it's been mapped to. So perhaps it includes a billing code or something of that nature. And then it also includes a text representation of the concept as well. Okay, so Dorothy makes her appointment and she goes to see Dr. Oz. And as Dr. Oz is carrying out this encounter, he's going to make some entries in his system as well. The first thing he's going to do is he's going to record a housing status for Dorothy. Social determinants of health are very important, so he wants to track that in case it's relevant for her treatment. So he chooses the patient is homeless code to represent Dorothy's housing status. And then he records some diagnoses as well. So he's going to diagnose Dorothy with concussion, with a loss of consciousness, that she has imaginary friends and has pleasant fantasies as well. So, and these are all SNOMED CT codes. I'm using SNOMED CT codes quite a lot through this presentation, but the APIs are not specific to that, except in a couple of very small cases that I'll mention. And so after Dr. Oz has made his diagnosis, he's going to refer Dorothy to a clinical psychologist, Dr. W.W. West, for a psychological evaluation. And so he sends that through. Oh, actually, before we get to that, to select those codes, we'll have a quick look at some of the ways that he does that. So again, he's using the expand operation. But I'd just like to have a look at the URL that we're using here. This is the URL of a value set, but it's not the URL of a value set that has been created on the server. This is what's called an implicit value set URL. And what happens is when you've got the LOINC code system in your terminology server, there are a whole bunch of value set URLs that are available for use without you having to create those resources in the server. So in this case, this is an implicit value set URL representing all of the members of a LOINC answer list. And LOINC has implicit value sets for answer lists, for the multi-actual hierarchy, and for all of the codes in LOINC. So we can send that request through to the server and it will come back with all of the LOINC answers that are in that value set. So that's where Dr. Oz can find the patient is homeless code. And similarly, when he's doing his diagnoses, we can also use implicit value set URLs for SNOMED CT. So in SNOMED CT, we have this value set URL here. And this is a hierarchy-based value set URL that represents all of the codes that are descendants of that 404.684.003 code. So that code and all of its descendants. And SNOMED CT has implicit value set URLs for hierarchy in this style, for members of a SNOMED CT reference set, for codes that satisfy an ECL expression, and we'll get into that later in the presentation. So again, this is a very big value set. This is all descendants of clinical finding, which is over 100,000 in most editions of SNOMED. So we're going to want to page the results. We don't want to see all of those. So we're going to ask for the first 10, and we're going to specify an offset of 0. So we're still looking at the first page. These are the parameters that we can use to page through an expansion when it gets very big. We're also going to ask for the designations. So designations is mostly used for two things in terminology. It's used for synonyms and it's used for language translations. It does have scope for other use, but those are the two uses that you typically see of designations. So we're going to ask to get those designations back in the expansion result as well. And we're going to pass in a filter. And this is how Dr. Oz can find that has imaginary friends code, for example. And we can see in the expansion result that there are some synonyms that have come back along with that expand request. So Dr. Oz sends this record across to Dr. West. And the first thing that happens when he does that is that Dr. West's EMR is going to try and validate the resources when they arrive. So Dr. West probably has some FHIR profiles that her system uses for the patient resource that she's receiving for the encounter, perhaps for the service request for the referral, the conditions that have been diagnosed by Dr. Oz, for the family member, the histories. And she's going to want to run her validator over that to check whether those codes are actually legitimate for the contexts in which they've been provided. That's probably going to use the FHIR validate operation on each of those resources, or perhaps even on a composition or a bundle that they've come across in. And under the hood, what's going to happen is that the FHIR validator, whether it's Graham's validator or something that's part of an EMR, is going to make lots and lots of calls to value set validate code. So every time it encounters a coded value, it's going to say, okay, what's the value set that's bound for that element? And is this code a legitimate member of that value set? So what we'll see, for example, is a check on the condition codes. So in that case, we'll see a call to the validate code operation. We can pass it a URL. And again, we're going to use a SNOMED CT implicit value set URL. This is all of the members of the clinical findings ref set. And then we'll pass in the code. So we'll say it's a SNOMED code and it's this 625-64004. And when we do that, the server comes back and says, yep, that's a member of the clinical finding ref set. That's a member of this value set. So you're good to go. As a second example, we can call the validate code operation again. And in this case, we're going to pass through this display parameter, the last display parameter. So this is the one that came through in the resource. So we're going to pass it in. This has imaginary friends. And when we send that through, the server comes back and it says, yes, this code is in the value set that the display text you've used has imaginary friends is not an acceptable display text for this code. So Dr. Oz has changed the display text on that, which in this case is fairly benign, but can be very dangerous if people are changing the text of a code to mean something quite different to what the code actually means. So having done all this validation, Dr. West completes her record and she does a psych workup of Dorothy. And she's going to diagnose her, in addition to the concussion, with depersonalization disorder and this reactive attachment disorder of infancy or early childhood. Again, these are SNOMED CT codes. And she's going to recommend a treatment. Dr. West is using a proprietary code system for treatment, and it's this RBSLP TAP3 code. So having done that, Dr. West submits her record to the Health Information Exchange. And one of the things that's going to happen there is that the HIE is going to try and map those codes. So it's going to take the 3 diagnosis codes and it's going to try and convert those into ICD-10 codes that they're going to use for billing, for example. So the HIE has built their own map between SNOMED CT and ICD-10 because there is no universal map between those code systems. It's very dependent on context. And it's attempted to map those across. It's managed to map the first 2. For some reason, it hasn't been able to map the third, and we'll have a look at that in a moment. And then it's tried to map the procedure code, but it doesn't understand that either. So we'll have a look at that as well. So the way it's doing this mapping is, as I said, the HIE's defined their concept map between these value sets. So it's going to call, we're going to call translate, the translate operation on the concept map resource. We're going to pass in the URL of the map we're using. We'll pass in the target value set. So in this case, it's the value set of all codes in ICD-10. And then we'll pass in the SNOMED code that we're interested in. And when we do that, we can see that the server comes back and says, yes, I found a match. The relationship that holds between these codes is an equivalence relationship. And it's equivalent to this S06.0 concussion code from ICD-10. So what happened to that unmapped code? So one of the things we can do for that, if we're working for the HIE and we're trying to explore what's happened here, is we can use the lookup operation. So that will give us all of the details about that code. So we can send that through with the code that we're interested in. And what happens then is that the server will actually decide what it's going to tell you about that code. So it is possible to tell the server which properties you want to know about. But in this case, we haven't done so. So it's up to the server to tell us what it wants to tell us about the code. And one of the things we can notice here is that it said that a property of this code is actually that it's inactive. So it's been retired from SNOMED CT. Now, one of the things we can do with SNOMED CT, and this isn't particularly common among other code systems, is that we can actually then ask SNOMED CT, well, is there a replacement code for this retired code? And as well as its implicit value set, SNOMED CT actually includes implicit concept maps for the codes that have replaced retired codes or that are the same as retired codes. So we can use that here. The URL that we're using there is the URL of this implicit concept map for what SNOMED CT calls the historical associations. And this one's the historical associations map for same as. And then we pass through our code, and the server will come back and say, yes, I've got a map for that. And this is one of the codes. There's actually two that are considered to be the same as that retired code that you were using. So after the HIE is done its processing, we'll cut across to an analytics person. So Glinda Goodwich is a researcher. She's doing a bit of analytics, and she wants to look at what treatment paths are being used for patients with mental health conditions. So to start with, she just says, okay, well, presumably all the mental health conditions are descendants of SNOMED CT mental illness. And she could very quickly query that by using the implicit value set for all descendants of mental illness. But when she does that, she finds her cohort's a bit too broad. She's got too many drunken munchkins in there, so it's all alcohol related. And she's really not interested for this study in intellectual disability, so she wants to exclude those conditions from a cohort as well. So she needs to build a value set to represent the conditions that she's actually interested in. So the way that we build value sets is by building up a value set composed, by building up the rules that determine which codes are in the value set. And there are 4 building blocks we have for doing this. The first is a whole code system. The second is we can include members of another value set. The third is we can actually list a specific set of codes from a code system. And the fourth is we can define some property, so some filter, where a filter is a property, an operation, and a value. So concept is a clinical finding, or active equals true, or something like that. And then once we've got these building blocks, then we can then start to combine them in ways that give us more expressive power. So we can, if we use multiple of these building blocks in the same include within a value set compose, then they'll get combined together as an intersection. So for example, if we have a value set and a filter, and they're in the same include, then we're specifying that only members of that included value set that satisfy the filter should be included. Whereas if we put them in separate includes, they're unioned together. So in that case, you would be bringing in members of an included value set as well as any codes that satisfy a filter. And then the last rule is that includes are always processed before excludes. That makes it deterministic as to which codes are in the value set. So once she's looked up these rules, Glinda is able to make up her value set, and she comes up with this value set. So the first include that she has says concept is a mental illness. And then she's going to include concept is a intellectual disability. So that takes out any codes that are both of those things, that are descendants of both of those concepts. Then she's going to define a couple of ECL constraints. So as I mentioned earlier, ECL is a query language that allows us to very powerfully narrow down the SNOMED CT codes we're interested in. Unfortunately, it only exists for SNOMED CT at the moment. So in this case, we're saying we're going to exclude any concept that's a descendant of mental illness and is in some way associated with drugs or medications, some kind of drugs or medications. And we're going to exclude any descendant of mental illness which is somehow associated with alcohol or one of its descendants. So having done that, Glinda's able to narrow down the cohort that she's interested in. And hopefully her FHIR server is going to help her in doing this. So what Glinda really wants to be able to do is run 2 query conditions like these. So this first one is a FHIR search path, which says, find me all patients with some condition resource whose code is below mental illness. So that's going to use the hierarchy to find things. So maybe Glinda's server is using the closure operation to keep a local cache of hierarchy relationships. Maybe Glinda's server's got some virtualized tables that are synchronizing with a terminology server periodically to make sure that it's correct. Alternatively, for her narrow cohort that she's defined, she wants to be able to say something like, show me all patients that have a condition whose code is in this value set. So you can use the in modifier and then pass in the URL of that value set that she's built. So there's no closure equivalent for value set membership. But if the server's limiting itself to known value sets, then it might be caching value set membership of concepts that it knows about and then updating those just when it sees new concepts, for example. Otherwise, it can just ask the terminology server whenever it finds out about a new value set. So the way that closure operation works, I think I've got enough time to cover this. The closure is a multi-step thing. So the first thing we can do is we can initialize the closure table. We're just giving it a name. And when we do that, every time we call closure, it's going to come back with a concept map. And that concept map consists of all the hierarchy relationships that exist involving the new codes that we've just provided. So in this case, we haven't provided any code, so there are none in there. So that's good. Then we pass in our 3 diagnosis codes. So the concussion code, the depersonalization code, and the reactive attachment code. Once again, there's no hierarchy relationships that exist between those 3. So the result of the closure operation is an empty concept map. Then we can pass in mental illness. And when we do that, then the closure operation comes back and says, yes, the depersonalization code that you provided is subsumed by, or the mental illness code subsumes that depersonalization code. So we're able to build up those hierarchy links, and we can store that on our local FHIR server, for example. Having done all this, Glinda works out that Dorothy is in her cohort, and she zooms in a bit, has a look at it, and she runs across this procedure code, this RBSLP TAP3 code, and she wants to know a bit about it. So what she's actually going to do this time is send through a batch request, so 2 terminology operation requests to try and get some information about it. So she's going to send through a lookup, and she's going to send through a translate operation to see whether her procedure map that she's defined has some entry for what this might represent in SNOMED-CT, so she can understand it better and feed it into her analytics. So when she does that, the server comes back, gives her some information. It tells her what it knows about this procedure code. So this procedure is tap your ruby slippers 3 times and say there's no place like home. And it maps to the SNOMED-CT code for magical thinking. So Glinda looks into the outcomes and finds that this procedure was very successful in treating Dorothy's conditions, and she builds a treatment protocol around it, and everyone's frightfully happy about it. So just to cover over then a bit of what we've looked at. So we've had a bit of a look at some of the terminology operations in FHIR and what they can help us with. So that expand operation that can either list all the codes in a value set or can help us search for codes in a value set. And then some of the parameters that we can pass into expand, mostly to shape the value set, the expansion value set that comes back from that expand operation by including synonyms or filtering concepts down using a text filter or paging through it. The validate code operation that we can use to check whether the codes that we receive are legitimate, and if we're receiving display text as well, to test whether that display text is correct with respect to the code as understood by the code system or the value set. The translate operation, which is really how we put a concept map to work, having written a concept map to find out what a code maps to. I didn't cover it in this presentation, but it is possible to invoke the translate operation with a reverse parameter. I'd urge caution if you're doing this. Just putting reverse equals true on a translate call doesn't mean that you've got a bidirectional map. It really is about asking the question, what codes map to this code, not what does this code map back to. Directionality is very important with concept maps. And then the lookup operation, which allows us to find details about a code, which is a little bit up to the server initially, but we can pass in the property parameters, the lookup operation, if we want to be more specific about what data we want to come back from that. I've also given a quick example of making your own value set. Making your own value set is a really important part of terminology. In this case, we were doing it for defining a cohort, which is a really useful thing to do. But if you're doing any profiling, you very often need to be building value sets to narrow down the set of codes, to bind the coded values that you're expecting in your profiled resources to what you consider to be acceptable. And then I've just briefly touched on some of the ways that we can hope to integrate FHIR servers and terminology servers, which needn't be different things, but can serve different roles, particularly to support that search functionality. To my knowledge, there's very little implementation of those search, those terminology-aware search modifiers in FHIR servers at the moment, but they're very, very powerful for for supporting semantic search of some of those clinical resources in particular. So I'm around for as much of the conference as I can stay awake for. It's coming up on 1 AM here in Australia, but I'd love to have some questions if people want to reach out and talk about either the things that I've talked about here or any other FHIR terminology services topics. There are a couple more FHIR terminology talks during the week. So I know Peter has a talk in more detail about SNOMED CT. I think that's on tomorrow. And then I believe Rob Housen has a talk about the future of naming system and concept map resources, which are two of the other resources that are in a little bit more of a state of flux than code system and value set. So if you're interested in those, then please check out those presentations. And I'm happy to take any questions now and also any offline questions afterwards.
Thank you, Jim. This was a great presentation. The Wizard of Oz has been a while, and it's tops as a refresher course. We do have a couple of questions from the audience. So to start with an interesting question, what if a code is not a valid member of a value set? Do we typically reject it? And this, of course, is more from the viewpoint of a FHIR server than a terminology server. Yeah,
I mean, it's really dependent on the context in which you're using it. I think rejecting it is carries with it its own risks because it may be that it's a code that has been provided by the user. And if that's a patient or a treating clinician, then it could be more of a risk to reject the resource and throw it away. If at all possible, you want to do the validation as soon as possible on the entry of the code. And this is another reason why you really want to do good profiling and binding value sets to only be the codes that you allow, so that people can only select codes that are valid. So the sooner you can do validation after those codes have been selected, the sooner you might be able to feed it back to the person who input that data and suggest that they might choose a different code.
Yes, quite right. Here in Holland, we also have the experience that doing rigorous qualifications and testing before going live really helps interoperability. Yep. So let's move on to the next question. What are the differences between terminology API as part of a standard FHIR server versus FHIR server integrated with a terminology server? And I think this goes back to one of your first slides.
Yeah, I mean, from the perspective of the user, it's very little. It really comes down to capability. So what you sometimes see is that dedicated terminology servers support more of the FHIR terminology services API, particularly when it comes to really complicated code systems like SNOMED CT or LOINC or some of the medications terminologies. So it really depends on the implementations of both the FHIR server and the FHIR terminologies server. So they can have the same capabilities or they can have different capabilities. And it's really that case where the terminology, if the terminology server has more capability than the FHIR server, then you can link them together. So you don't have to rely on your FHIR server implementer doing all of the terminology implementation. The Terminology Services API provides a way of allowing that FHIR server to call out to a specialist server when it needs to, if that's what you want to do with your architecture.
Thank you, Jim. This is a really tough question, but I'm going to ask it anyway. How to manage terminologies independent of FHIR version?
Well, one of the things that really helps with this is that the code system and value set resources are normative. And this was something that when we did migration from STU3 to R4, they were already very mature resources. I think they were at maturity level 4 or something when R4 first came out, and there were very few changes from STU3 to R4. And now they've gone normative. So there basically can't be any changes. So you do tend to have syntax compatibility even across FHIR versions for those resources. It's not something you can rely on completely going forwards, but it makes a migration path if you do need to migrate your FHIR resources much easier. The other thing that can help you with this is Some servers now support multi-version FHIR APIs, so you can pass across the FHIR version in the one of the headers and in one of the request headers, and then some servers are capable of dealing with either R4 or R5 requests on the same server. I'll have to confess that ours doesn't yet do that, but when you're a server that deals mostly with normative resources, that becomes a much more attractive option because you've got a lot less to do to manage the variability between what those resources look like between versions. So supporting a multi-version API is something that becomes attractive.
Thank you. Next question. We have plenty of questions, which is always a good sign.
Yep.
Do the resulting expanded values depend on the FHIR profile used by the server?
Do they depend on the FHIR profile used by the server? Yes, they will. So if your server is profiled to use specific value set bindings for example, medication .code, then and you make a request using the context parameter, then yes, you could get different results depending on how that server is configured with respect to profiles. You'll also get different results from different terminology servers depending what other parameters you pass in. So a really good example for that is the filter parameter, which allows you to pass in a free text filter. The way that different servers process that filter to narrow down the set of codes varies quite a lot. And there is a tool that one of my colleagues has built, and I'll put this in the response to the question in Hoover after the talk, called the VS tool, where he just sends off the same expand request with a filter to multiple different terminology server implementations and shows the difference in the concepts that comes back. And you do see quite a lot of difference, particularly for that filter parameter in how the servers behave, and even for some of the other parameters, even the count and offset parameters and various of the other expand parameters. So you will see some variation in terminology servers in terms of the order of codes that come back, how many come back in a given page, and which are considered to match a filter, for example.
Yes, thanks. The next question is, does Unified Medical Language System, the UMLS, have any potential to help in concept mapping?
Look, it has some potential, but you need to use it with a lot of caution. So if you're relying on the concepts that you're intending to map between being linked to the same UMLS concept, you should keep in mind that though that association is without context. So if you're mapping, for example, SNOMED CT codes to ICD-10 codes for the purposes, and I'll use an example we've used for the purposes of billing in Australian hospitals, then you cannot rely on the proximity of those codes on the same UMLS concept, because that it does not take into account that context of that billing context, and you will have bad maps in that map, and depending on what you're using that map for, a bad map can have clinical safety implications. So you have to be really careful about considering context before you use any map off the shelf, including UMLS, which has a very, very broad remit. So it has potential, but there's a lot of caution to be exercised there to make sure that it's fit for purpose.
Thanks. Next, this is a very broad question, but it's also a very essential one. How many operations can you batch at any one time? What are the rate limits set on per client basis when using expand, validate code, translate, lookup? So I was thinking too, some of the stuff you showed, I think that will take a lot of time on the server.
Yeah. Sometimes it'll depend. That also depends wildly on the server implementation you're using. So some servers will, well, they won't make an explicit guarantee, but you could rely on them to have sub-second response times for all of their operations. And in fact, well, for example, in our server, things like lookups and validate codes and translate operations are usually in around 10 milliseconds. They're very, very fast. But that said, if you're bandwidth limited or you're sending through a lot of these things, then you can batch them up. The batch limit is entirely up to the server. We have sent through batches of up to 1 million requests. It works. It's not actually more performant. One of the trade-offs you have to be aware of when doing batch requests is that batches are HTTP post requests, and so they can't be cached. Whereas if you send through, for example, an expand request as a GET request, then that can be cached. Just using HTTP caching, and HTTP caching can make a huge difference to the performance of your interactions with any FHIR server, and particularly a FHIR terminology server. So there's trade-offs. I think in Shrimp, which does very big batches of things, for one of the operations we were doing, we did a whole bunch of testing, and the metrics told us that a batch of about 100 was working for that particular interaction. So doing a bit of testing to work out where the sweet spot is worthwhile doing as well for determining batch sizes.
So final question, given the time, does Loink provide the same feature as SNOMED CT shown in the presentation, code history and replacement?
It'll depend on how well implemented the Loink import is in your terminology, in your FHIR server or your terminology server. Loink does have inactive status encodes, so you'll certainly get that back. The implementations of Loink that I've seen from Regenstrief and ours and the Happy implementation don't have support for replacement code lookup, but it's not impossible. There is some data like that in the Loink distribution files, if I remember correctly, so it might be possible to do it. The reason I mentioned the SNOMED CT one is that the SNOMED CT page in the FHIR spec actually specifies those maps as a standard part of a SNOMED CT rendering in FHIR. And that at the moment, that's not defined for Loink, but if Regenstrief are listening and are looking to do that, I'd heartily encourage them to do it. It's a really useful feature for maintenance of value sets and concept maps.
I can partially confirm that. So in the Regenstrief, in the distribution of Loink, there is a map resource, which has a mapping for discouraged and deprecated codes. I'm not sure how complete it is, but it is there. So thanks a lot, Jim, for a great presentation. We're already 2 minutes over time. There are a few more questions not answered yet, but we'll be answering them in the Whova app.
Yep.
So thanks again.
Certainly will.